Okay, the chemical reactions of acids. I suppose technically it's going to be chemical reactions of acids and bases, but you mainly look at a bunch of different reactions that acids undergo, and one of those reactions is with bases. So we'll just call it the chemical reactions of acids. There is a list of strong acids and strong bases, as well as a couple of weak ones that you are expected to know by name and formula. They are listed on this page. Whatever it is you need to do to memorize them, whether it's use flashcards or just read them off this page, make a Quizlet, these are the ones that you need to know. Strong acids, strong bases. The weak acids are here, and the weak bases are here. Now, weak acids, really anything with a COOH on it, an organic acid is a weak acid, and anything based off of ammonia, so something with an NH2, is called an amine, and those are all going to be basic. So since we're looking at things that react with acids, we're going to look at what categories of substances will react with acids, and therefore what categories sort of are going to act like bases. Whenever we have an acid react with something, the other thing is sort of acting basic in that situation. So the other things we have going on are metal oxides, metal hydroxides, ammonia and amines, and carbonates and hydrogen carbonates. Just a point of vocab, alkalis is a term that's used to discuss bases that are soluble in water and that yield hydroxide ions in solution. So especially like these could all be referred to, these top three, as alkalis because they're very soluble in water and they produce hydroxide. The key thing to remember about any chemical reaction of an acid is that they're all going to produce a salt. And a salt is just a way of referring to an ionic compound. So in any acid-base reaction, really the key to figuring it out is the first thing you do is figure out what's going to be the positive ion and what's going to be the negative ion in the product. So the nice thing is that the acid, if we highlight that, we're going to make it red, the acid always produces the anion. So that's kind of what I hold on to. And then by process of elimination, the base is always going to produce the cation. So we'll just highlight blue for base, and there's our cation. So if you look at the acid like HCl, you should associate the H of the HCl as being the H+, the proton that's going to get donated. And so whatever is left over after you give away an H+ is going to have a negative charge, and that's going to be the anion. So in HCl, Cl- is going to be the anion. I can do that. There we go. Okay. And if you look at any base that's a hydroxide, ignore the hydroxide. That's the part that's acting as the proton acceptor. That's the basic part. And so whatever is left over is going to be your ion. So if we come over here, we're going to have an Na plus as the ion. And it's pretty obvious at this point what the salt is going to be. The salt is going to be NaCl. Because 1 plus and 1 minus and everything is balanced. Okay? So if NaOH and HCl react together, then you should know that the Na plus is going to be the positive cation, and the Cl minus is going to be the negative anion, and then they're going to come together to form NaCl. And you can already kind of notice if you ignore the Na and you ignore the Cl, what's left over from NaOH and HCl? Well, it's OH and H, and the other product of this reaction is going to be water. There's two H's and an O. We're going to get to that again in just a second. I want to do one more example. We've got K, so the ion here is going to be K+. And over here, if we ignore these two H's, those are both H+, then we're left with SO4, 2- as our ion. And now, if we put together the salt, the one thing to remember is that when you form salts, you have to crisscross your applesauce and make sure that everything is balanced. And because K has a 1+ and this has a 2-, I'm going to need 2 of the K's to balance out the 2- charge of the SO4. And so the salt that we form is potassium sulfate, and its formula is that. So it's pretty straightforward making the salt. I'm going to leave a few more examples for class, but that's the basic premise. So There's sort of three general categories of reactions. We have reactions of acids with just metals, and that produces a salt, as all these reactions are going to produce salt, and the other product is hydrogen gas. Expected observations with this reaction is fizzing because of the gas, warmth because it's exothermic. So here's an example. We'll just do one, and I think you'll get the idea. So when you look at a reaction, always start with the acid, and remember that the acid gives you the anion. And so bring that over. Whatever is reacting with the acid is going to provide you with the cation. So that's going to be Mg. The thing to remember is that Mg is a 2+ and Cl is a 1-. It's important to remember your ion trends. So if we crisscross applesauce, we end up with MgCl2 as the salt. And as a result of having two Cl's here, I need to come back here and put a 2 there. And what's nice is if you ignore the Cl and the Mg, since we know they end up as the salt, all that we have left is two H's, and that's what turns into our H2 gas. So the acid reactions, if you remember to make the salt first, the other product should become very readily apparent when you do it. In our reactions, acids are going to be aqueous, metals are going to be solid, and the salts that are produced are going to be aqueous. So that's all we'll do for this one. Moving on. Okay, acids react with bases like hydroxides to produce salt and water, and acids react with metal oxides to also produce salt and water. There aren't really any observations here because these are usually pretty boring. For the bases one, the observation is that there's warmth because it's a classic exothermic reaction. For the metal oxide reaction, the only observation you would see is that you'd see the oxide dissolving. So that could be something you'd observe. All right, now if we try out the first one, again, you got to make your salt, the Cl- from the acid, and the Li+ from the LiOH, and that's going to be aqueous. And that leaves H, and it leaves OH, which is really another way of saying H2O, which we know is going to be liquid. This would be aqueous, and this would be aqueous. For the sake of time, I'm going to skip past that. Now I've got one with a metal oxide, sodium oxide. So again, make the salt first. So the acid gives you the negative ion, that's nitrate, and the other thing gives you the positive ion, which must be sodium. And so there's my salt. Na is a 1+, and NO3- is a 1-. Or NO3-, nitrate's a 1-. So I clearly need two of these because I have two sodiums on this side. And that means I need two of these to balance out the nitrates. And now what's left over after I made my salt is two H's and an O. And sure enough, there is my water. Okay, the last one that doesn't quite fit into the category of making salt and water is when you have ammonia. Ammonia doesn't have an OH on it. And so ammonia acts as a base only as a proton acceptor. So as the proton leaves the ethanoic acid, and this is the acidic proton in any carboxylic acid, NeCOOH. As that goes onto the end, it's going to create our cation. So ammonia is a little bit different, and it creates ammonium, which is a positive polyatomic ion. And what's left over here is the anion of CH3COO-, that's referred to as ethanoate. And now we have a 1+ ion here, we have a 1- ion here, and we've made our aqueous salt, and we're done. So a subtle difference in the reactions is acid plus base makes salt and water, but acid plus ammonia, or an amine, makes just the salt. So if you want to add a clarification note there, that's fine. And the last category of reaction we're going to talk about is acids plus carbonates. So carbonates or hydrogen carbonates. These will produce salt, carbon dioxide gas, and water. This is the classic volcano reaction that you may have made as a kid with vinegar and baking soda. The main reaction here is that there's fizzing, but it's not exothermic. So when you do these, you may get tired of hearing this, but the thing to do first is to make the salt, which is going to be Na and Cl, once again finding the negative ion from the acid, and then the positive ion from the other reactant. These ones are a little tricky. If you look at what's left over, it might look like you should make this. If you put them together, you could get, there's two H's and there's CO3, and you'd make H2CO3, which is a substance called carbonic acid, but this readily breaks apart into water and carbon dioxide. So you don't even write the carbonic acid, you just write how it produces these. And so the salt is in the aqueous phase, water is liquid, and the carbon dioxide is gas. And so whether it's a carbonate or a hydrogen carbonate, the products are the same: salt, water, and carbon dioxide. So here's your chemistry syllabus, and most acids have observable characteristic chemical reactions with reactive metals, metal oxides, metal hydroxides, hydrogen carbonates, and carbonates. Salt and water are produced in exothermic neutralization reactions. So I think we've covered those understandings. I guess one point that I maybe glossed over here with metals, not all metals react with acid. Things like copper, gold, silver, platinum, the very stable metals that are good for jewelry are too stable and they do not react with acids. But the more active metals like magnesium, aluminum, zinc, calcium, they will react with acids. So that's the reactions of acids. It's a bit of memorization to learn the different acids and bases by name and formula. But after that, if you can just remember the technique of always producing the salt first and then figuring out the other products afterwards, it's actually fairly simple to get the reactions and the products of acids.